Hello viewers, in today's lecture we are going to find the mean, variance and standard deviation of first n natural numbers. So let us first see what are natural numbers. So the first n natural numbers are 1, 2, 3, 4 and so on. Since we have to take the first n natural numbers, so here we have n, right? So these are the first n natural numbers. Now we have to find the mean, variance and standard deviation of these n natural numbers. So what we will do, let us first find the mean of these n natural numbers. So we know that the formula for mean is sum of observations divided by total number of observations, right? So the sum of observations, so here the observations are 1, 2, 3, 4 and so on. So the mean can be denoted by x bar. So the sum is 1 plus 2 plus 3 plus 4 up to n, right? And the total number of observations are n. Now here we have the sum of first n natural numbers. So we know that the sum of first n natural numbers, which is denoted by sigma n, is given by n plus 1 by 2. So we'll directly use this formula. So here we have n plus 1 by 2 divided by n, right? So this n is this one. So we can write it n plus 1 divided by 2n. Now this n and n get cancelled. So the mean of n natural numbers is n plus 1 divided by 2. So we'll write this result here. So the mean is n plus 1 divided by 2. Now let us find the variance of the first n natural numbers. So for this we have the formula for the variance, that is sigma square is equal to 1 over n sigma xi minus x bar whole square, right? But here we are not going to use this formula. So instead we'll use the formula sigma square is equal to 1 over n sigma xi square minus the square of the mean, right? So this formula can be obtained from this one, and here this term sigma xi square is the sum of the squares of the first n natural numbers. So sigma xi square can be written as x1 square, x2 square up to xn square. So what is x1? x1 is 1, so we have 1 square. x2 is 2, so we have 2 square, and so on, and xn is given by n, so we have n square. Now viewers, here we have to find the sum of the squares of first n natural numbers. So here again we'll make or we'll use a direct formula, that is the sum of the squares of first n natural numbers is given by 1 over 6 n plus 1 2n plus 1. So here we'll write this expression. So we have 1 over 6 n plus 1 2n plus 1. So now we'll substitute the value of sigma xi square here, and the value of the mean, that is x bar, as n plus 1 by 2. So let us see what we will get. So sigma square can be written as 1 over n. Here we have 1 over n times the value of sigma xi square, which is 1 over 6n, n plus 1 and 2n plus 1, minus the square of the mean, which is n plus 1 by 2 whole square. Now this n and this n get cancelled, so we have n plus 1, 2n plus 1 divided by 6, minus, and this term becomes n plus 1 square divided by 4. Now taking the common factors, so we have n plus 1 as a common factor here and 2 in the denominator, so we can take out n plus 1 by 2 common. So inside the bracket we are left with 2n plus 1 divided by 3, because 2 3s are 6, minus n plus 1 times n plus 1 is n plus 1 square, and here we have 2, right? Now simplifying this term, so we have n plus 1 by 2, and taking the LCM, so we have 6, and 2 times this term, so this is 2 times 2n plus 1 minus 3 times n plus 1, right? Okay, so this is n plus 1 by 2, and inside the bracket we have 4n plus 2 minus 3n minus 3, right? Minus 3n, minus 3 times 1 is minus 3, so divided by 6, and this is n plus 1 by 2 times 4n minus 3n is n, and 2 minus 3 is minus 1 divided by 6. Now here we have n plus 1 and here we have n minus 1, so here we'll make use of the identity, that is a plus b times a minus b is equal to a square minus b square. So here we have n square minus 1 square divided by 2 6 are 12, and this can be written as n square minus 1, because 1 square is 1 divided by 12. So viewers, here we have obtained the variance of the first n natural numbers, that is sigma square is given by n square minus 1 divided by 12, right? So this is an important formula. Now for the standard deviation, we can write the standard deviation as a square root of the variance, that is sigma square. So we have square root of this term, that is n square minus 1 divided by 12. So this is the standard deviation. So this is the formula for standard deviation, this is the formula for the variance, and this is the formula for the mean, right? Now suppose we have to find the mean, variance and standard deviation of first say 5 natural numbers. 5 natural numbers. So it means we have to find the mean, variance and standard deviation of 1, 2, 3, 4 and 5. So what we will do, we'll simply substitute n is equal to 5 in these three formulas, right? So the first one, that is mean, is given by n plus 1 by 2. So we have 5 plus 1 by 2, that is 6 by 2, that is 3, right? And the variance sigma square is given by n square minus 1 divided by 12. So substituting n equal to 5 here, we have 5 square minus 1 divided by 12, that is 25 minus 1 divided by 12. So this is 24 by 12, and this is 2, right? 12 ones are 12 twos are. So the variance is 2, right? And the standard deviation, that is equal to square root of the variance, right? And the variance is 2. So we have square root of 2. So this is how we apply these three results to any number of natural numbers.